Knock or detonation is the biggest killer of any performance engine, so it makes sense that this is one of the key operating aspects we want to be aware of. As we discussed in the EFI Fundamentals course, there are a number of parameters that can cause knock, but primarily it's the result of heat in the combustion chamber exceeding the auto ignition point of a particular fuel. With this in mind, any change that results in a rise in combustion temperature can make an engine more prone to knock. Since the excess fuel of a rich mixture tends to help cool the combustion charge, it makes sense that a leaner mixture will result in a higher combustion temperature. In turn, this can make the engine more likely to knock. As long as you understand this, we can easily deal with this in our tuning. If your engine is already knock limited, a leaner mixture will almost certainly require some ignition timing to be removed to avoid the onset of knock. If your engine previously was not knock limited, you may find that a leaner mixture is sufficient to cause knock. For this reason, care is required when using a leaner mixture, as timing may need to be removed. The flip side of this situation is that often in a severely knock limited engine, we can gain a power advantage by choosing to run the engine with a richer than typical air-fuel ratio. This can reduce the combustion temperature enough to allow more ignition timing to be used without knock occurring. From my own experience, I usually find there is little to be gained from this scenario by running richer than, say, 0.75 lambda in turbocharged engines or 0.85 in naturally aspirated engines. It goes without saying that at all times when you're tuning an engine, quality knock detection equipment should be used to ensure you're not operating the engine in knock. Knock can cause severe engine damage very quickly and must be avoided.